Hi everyone, I'm excited to talk to you today about one of my favorite labs that I do during the year. If your students love lab days but struggle to connect them to actual chemistry concepts, this root beer lab might be exactly what you need. Initially, it's going to seem a little fluffy to you, but you'll see that it has a lot of really good chemistry in there, and the kids love this lab. So, I'm talking about making root beer with my class. So, I do use dry ice to make the root beer, and it's going to incorporate phase changes, intermolecular forces, acid and bases, and then we'll talk about ocean acidification and some other real world consequences. So the way that I start off my activity here is I have a Google slideshow that I use. And at first it does have some safety information in it. And I do want to let you guys know that I am going to link my Google slideshow in the show notes and the worksheet. I do want to give you guys a heads up. This is not something that I have what I would quote unquote called TPT-ified. It's really just something that's just sitting in my Google Drive, and I just wanted to share with you guys in case you were interested in trying the root beer lab out for yourself. So after we talk about the safety, I'm going to give them a little bit of history. It only takes a couple of minutes. I'll just mention that root beer was once used as a medicine. They might have heard it called sassafras before. I'll sometimes mention if they've ever seen like a Western movie and they've seen what we might call a snake oil salesman, that was somebody who would sell stuff that they would say is medicine, but it necessarily wasn't medicine. And so I like to also mention this idea about snake oil salesmen because it comes up in some of their English writing prompts. We've been doing like a little cross curriculum stuff. And anyways, since root beer was made with this sassafras root, and I do have some dates in there, but the idea is that the sassafras root was found to be carcinogenic. And so now today, root beer, even like all natural root beer, is not made with sassafras. It's made with other spices and herbs. And when I make it in my classroom, we are just using water, dry ice, sugar, lots of sugar, and root beer extract. The idea behind me telling this little root beer story is I like to mention that science is always evolving and changing, like we're updating our information, and what we think is safe can change over time. This might date me a little bit, but I remember we used to talk about how margarine was good for you to eat, and now we've kind of gone back to butter as being like the better thing or the safer option to eat. To start off with, what I'll do is I will take my bag of dry ice and I will hold it up for the students to see. I will ask them if they think that this is water that I'm holding up. I haven't told them what's in the bag yet. And so they'll say, well, I'm not seeing it drip, so I don't think it's actually just like water, like regular bags of ice. What they can see as I'm holding it up is they can see like a gas coming off of it. Now, depends on the class that I'm dealing with. If I want to be a little bit more high level, I'm going to say, guys, well, actually, this like little foggy stuff you're seeing come off is not actually the carbon dioxide because the carbon dioxide is colorless. What's actually happening is that the dry ice is so cold that it's making the water molecules around this plastic bag condense. And so what you're actually seeing is the water molecules. And then we'll talk about what's happening. They can kind of see that the bag is maybe getting a little bit smaller. I'll have some cups already on my counter with some small pieces of dry ice. They might have noticed that the dry ice particles in the plastic cups are getting smaller. We have done states of matter right before this and gases. So the kids have had that context before. So I like to relate this back to our previous content that we've learned about and just reiterate that this going from a solid to a gas is called sublimation. And as we know, our students are pretty familiar with most of the phase changes, but really sublimation is one of the ones that they need a little bit more help with. Then after I give them a little demo of holding up the bag, I'll go ahead and I will just put the dry ice in a very large plastic container that I have. When I first started off, I just used a 5-gallon food safe bucket, like something that you might store like rice in. And then now I was able to purchase, and I got it off of Amazon. It's basically a large 5-gallon container that has a spout at the bottom. And for me, this spout is a huge upgrade than trying to pour it from this 5-gallon bucket. So the idea is I just put the dry ice back in there. And then now we're going to jump into some more teaching time. So my students have learned about phase diagrams before. And since we just talked about sublimation, I want to refer back to these phase diagrams. So the ones that I have in my PowerPoint are just water and carbon dioxide. We'll look at water. I'll remind the students that we're 1 atmosphere. Let's go ahead across the chart, the diagram at 1 atmosphere for water, and you can see how you could be hitting all 3 phases, solid, liquid, and gas. Then we do the same thing on the carbon dioxide phase diagram, and then at 1 atmosphere, if you move your finger across the diagram, you're going to see that you can only have the solid and the gas state. So there's our example of sublimation. And then I'll talk about what conditions would we need to have our carbon dioxide be in the liquid phase, and we'll look at it together and we'll see that we would need to have 5 atmospheres of pressure to even be in the liquid phase for carbon dioxide. At this point, I'll usually draw a Lewis dot structure of carbon dioxide molecule up on the board. I'll remind them, even though carbon dioxide has some polar bonds, it's non-polar because those dipoles are canceling out. So if I have a non-polar molecule, the only type of intermolecular force it's going to have are London dispersion forces. I remind them that London dispersion forces are very weak. And so the idea is we need really, really high pressure for our carbon dioxide to be in the liquid phase, because the only thing that's bonding those molecules together is this weak London dispersion intermolecular force. So then after we go over the phase diagram and maybe their eyes are glazing over, now we get back into doing some more observations. At this point, I'll just review the safety precautions. I'll give each group 1 plastic cup, and it'll have like a small piece of dry ice in there. I would say the piece that I normally give is about the size of like my AirPod case. So it's a pretty good size, but it's not like a giant piece they're getting. And the kids can hold the cup. They can see how the cup is really cold. They can breathe on it and kind of make some of that own spooky fog. I'm not sure if I mentioned already, but when my kids were little and we would go Halloween trick-or-treating, I think all my kids would call it spooky fog. So I kind of mentioned like that gas that you can see as the spooky fog. So they'll breathe on that and see the fog. And then I'll have them pass it around. And then once everybody's had an opportunity to observe it, then I have them pass it back up to me. Not that it's like a huge deal, and not that I think anybody's going to really get hurt, but I don't want anybody messing around with that dry ice. So again, we'll bring those cups back. I'll put the cups back on my front demo table, and the kids can continue to make observations about the size of the dry ice that is in the containers. So then after that, what I'll do is I put the dry ice back in my 5-gallon container. And at this point, I'm going to go ahead and add a gallon of water. And so this is going to make that spooky fog. And so what I'll do is I'll have the kids come up like group by group, and 1 or 2 at a time. They can put their hand in the container. Again, I mentioned to them, please don't touch the water. Please don't touch the dry ice. We don't want your dirty hands in our root beer. But what they can do is they can scoop out some of this dense carbon dioxide. And they think it's really cool that they're able to hold this in their hand. This is the first experience that some of these students have had with dry ice. I do mention kind of at the very beginning, I'll ask the kids, have you ever used it? And sometimes I'll get kids that say, oh, we use it when we go hunting. We might use it when we go camping. But I feel like less and less kids are doing those activities now. So it's even fewer students that have been exposed to dry ice before. Then after I add the water to it and everybody's had a chance to check out the fog, I'll go ahead and I'll add some more water to it. I'll add the other 2 gallons to it. And at this point, the kids can like really see it bubbling. They can really see it going from that solid to that gas phase there because the water's clear, my container's clear. Then I'll add the root beer extract and the sugar, and then we'll jump into acids and bases. So then we'll just talk about how sodas are acidic. I'll ask, why is the soda acidic? And then I'm like, well, if we're making root beer, are we going to be making this acidic? And the kids are like, yeah. And so I asked them, why do you think, like, what ingredient that we put in here is going to make it acidic. I'm like, is the water acidic? They're like, no. I'll ask if it is the root beer extract. I'll read you some of the ingredients. Does that sound acidic? No. And we finally get down to, well, what must be the thing that's making it acidic is the dry ice or the carbon dioxide. Then we'll talk about how carbon dioxide is in your sodas. And the idea is if they've ever had a flat soda, it's because it didn't have the carbon dioxide in there. And we'll talk a little bit about the chemistry, about how carbon dioxide plus water is going to form carbonic acid, and that's what's reducing the pH of the soda. Also, I want to mention that as I am stirring this mixture after I add everything together, what I'll do is I'll take my big wooden spoon that I have and I'll stir it around and I'll make like a witch sound. Ah, 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 ah. So it's just something corny that the kids think it is funny that I do that. I'll go ahead and I will put the lid onto the container that I have. I do want to show the kids that there is gas that is escaping from this container because it could be dangerous to have gases contained in a sealed container, but we do need to let the root beer brew. Going back to my witch's idea there, we do need to let it brew. It's giving it a chance for the sugar to keep mixing because the dry ice is bubbling and for that carbon dioxide to spread throughout the solution that we're making. And so I'll set the container aside for about 15 minutes and then we'll jump into environmental chemistry here. I asked the kids, have you ever heard that the oceans are becoming more acidic? And some have. And then again, we'll talk about like, well, why do you think they're getting more acidic? And then we'll go back to this idea of like, well, what was making our root beer acidic? Oh, it was the carbon dioxide. And then I'll ask, are the oceans absorbing carbon dioxide? In a previous activity that I have, that it's all about carbon, they'll see that plants and the ocean are carbon sinks. So the idea is that the oceans are absorbing more carbon dioxide, so they are getting more acidic because of that formation of carbonic acid. I do have a couple of videos from the Alliance for Climate Education that I show. One's kind of like a general video and one's a little bit more specific into the chemistry. But I like to talk about how, since we're making it more acidic, two things are going on. We're reducing the amount of carbonate ions that shellfish and like creatures with exoskeletons need that carbonate to form. So with less carbonate in there, it's harder for them to build their shells. And then if they have softer shells, they're going to be easier to eat, reduce the amount of, say, clams that maybe another organism will eat, and then that'll have big effects on the food web that's in the oceans. Another thing, if I have time for it, is I will have some seashells in the little plastic cups and they'll have some vinegar. One of the things I'll sometimes do, especially if you're buying the seashells from like a store, they might be kind of shiny already. I'll take a little nail file and I'll scruff them up a little bit, and then the kids can drop some vinegar on the shells. They can see kind of some bubbling and some dissolving there. We have seen this idea of vinegar and baking soda earlier in the year. So I just kind of tell them that like the calcium carbonate is like chalk, and so it's similar to this baking soda idea. After we talk about the environmental chemistry, we watch little videos, then I'll have the students complete their worksheet at that time. I'll give them a couple of minutes to read over it. I'll ask them if they have any questions. And then once we are done there, we can partake in some of our root beer. I do have the kids bring in the dry ice for me, and I have them bring in cups, and I usually have the sugar already available from previous labs in the year. And then I do also buy the root beer extract. We used to be able to find it pretty easily, but now it's a little more challenging to find it. So I just honestly order it off of Amazon. There is a brand, and I think it starts with a W. The package looks a little old-fashioned. It tastes more like cream soda than actual root beer. So depending on what you personally like or your students like, just kind of take that into consideration. So once I am ready to pour our cups, I'll just fill up the cup a quarter of the way with root beer, because some kids are going to love this and they're going to want to come back for more, and some kids are not going to like it. They just wanted to try like a drink or two of it. If kids want more of it, they can get a second helping and fill up their cup. I do have some kids with some diabetes, and there is like 3 pounds of sugar in this thing. So I do like to mention that to the students. Since I was just mentioning the supplies that I use, a couple of tips that I have for you. If your kids are buying the dry ice, or even if you're buying the dry ice, I would call around to the local stores and see if they have it. I'll call the store ahead of time and I'll have them hold it for me. Or if my students are buying it, I'll be like, hey, can you set some aside because some of my students will be coming in the morning. Sometimes kids do buy it at night, but dry ice does what dry ice does, and it's going to sublimate. And you might have bought 5 pounds the night before, and when you bring it into school the next day, it's maybe only 2 pounds. As I mentioned, I think that this lab is like super fun. I get to tie a lot of different concepts into it. I get to be a little bit silly with my witch brewing. So if you've never made root beer, this might be your sign. This October, I am planning on opening up the Confident Chemistry Teacher Lab membership. And if you'd like to be one of the first people to learn about it, to get the information, and even get the founding rate. And if you want more labs like this, join the wait list. I'll include in the show notes a link where you can sign up for the wait list. And as always, guys, keep inspiring, keep experimenting, and keep being awesome in your classrooms. Happy teaching.